Alright, this lesson is over Chapter 10, Section 3, Operations with Radicals. Now, we've talked about operations. Operations are addition, subtraction, multiplication, and division. Recall, we've done adding and subtracting expressions, like 3x minus 5x plus 4x. What did we do to add and subtract these expressions? Well, we combine like terms. Now, it is exactly the same when you do operations with radicals as you do operations with variables. The difference is like terms so operations with variables, we have 3x minus 5x plus 4x, which would give us 2x. Because 3 minus 5 is negative 2, negative 2 plus 4 is positive 2. It is exactly the same with radicals, except your like terms for radicals are terms that have the same radical, as opposed to terms that have the same variable. For example, we have this 4 times the square root of 2 and 5 times the square root of 2. These are like terms. So, let's try a problem that is operations with radicals. Let's take 3 square root of 2 minus 5 square root of 2 plus 4 square root of 2. Well, we combine this just like we did 3x minus 5x plus 4x. You do 3 minus 5 plus 4, which is 2, so your final answer is 2 times the square root of 2. Now, just like when you're combining variable expressions, your variables never change. So when you're combining radical expressions, your radicals never change. The only thing that can change the number inside a square root is when you multiply it by another square root. Okay, let's try another one. Let's take 15 square root of 3 minus 4 square root of 5 plus 6 square root of 5 minus 11 square root of 3. Now, you will notice that this has two different radicals. This is like a variable expression that has two different variables. So if I replaced these radicals with variables, this is what my expression would look like. Now, how would you combine it with two different variables? Well, you combine your like terms. 15x and 11x gives you 4x. Negative 4y and 6y gives you 2y. It is exactly the same with radical expressions. You combine your like terms, and 15 square root of 3 and 11 square root of 3 gives you 2 square root of 3. Negative 4 square root of 5 plus 6 square root of 5 gives you 2 square root of 5. And that's your final answer. Look at this one. We have the square root of 27 plus 4 times the square root of 3. Your first thought will probably be, well, they're not the same, so you can't do anything. But if you notice the square root of 27, that can be simplified. Now, we know how to simplify square roots. We have to factor it using the tree. 27 breaks apart to 9 and 3. 9 breaks apart to 3 and 3. So there is a pair of 3's and 1 3 left over. That changes the square root of 27 to the square root of 3 times the square root of 3. We keep plus 4 square root of 3 because we didn't do anything with it. Now you will notice that the square roots are the same, the square root of 3 and the square root of 3, which means you can combine them. 3 plus 4 gives you 7 times the square root of 3. And that's your final answer. It is always important to simplify your radicals, because it may look like you can't do anything, but most of the time you can. Now, there will be some times when you won't be able to combine things, because they'll simplify and they won't have the same radical, which is fine. Simplify them still, because if they're not simplified, your answer is not done, and you won't receive full credit. So, let's try another one where you have to simplify. let's take 4 times the square root of 54 plus 2 times the square root of 24. 54 simplifies. You break it apart to 9 and 6. 9 breaks apart to 3 and 3. Now, 6 also breaks apart to 3 and 2, but I'm not actually going to do that because I'm going to end up multiplying it back together anyways, because that 2 and 3 doesn't pair with anything. So, I break apart 54, and it becomes 3 times the square root of 6. But you can't forget the 4 on the outside. The pair of 3's multiplies times the 4 to give you a 12 square root of 6, because 6 is what you have left over. Let's do the same thing with 24. We break apart 24, and it gives us 4 and 6. 4 breaks apart to 2. The 2 multiplies times the 2 outside. The pair of 2's multiplies times the 2 outside. And you get plus 4 square root of 6 because you have the 6 left over, which gives you a final answer of 16 times the square root of 6, because 12 plus 4 is 16. Yes? Try this one on your own. So, remember, you're going to have to pause your video while you work this out, and then unpause your video to see if you got the right answer. So, pause your video. Alright, so the answer you should have gotten is 4 times the square root of 5. So, let's explain how we got that. First, let's simplify the square root of 45. 45 breaks apart to 9 and 5. 9 breaks apart to 3 and 3. The pair of 3's multiplies times the 3 on the outside, and you get 9 square root of 5. Now let's simplify the square root of 20. 20 breaks apart to 4 and 5. 4 breaks apart to 2 and 2. The pair of 2's comes to the outside, and you have 5 left over, so that is plus 2 square root of 5. And last but not least, let's simplify 245. 245 breaks apart to 49 and 5. 49 is 7 and 7. The pair of 7 comes to the outside, which leaves you with minus 7 square root of 5. Now, when you combine all your terms, you do 9 plus 2 to give you 11 square root of 5. 11 square root of 5 minus 7 square root of 5 gives you 4 square root of 5. And that's your final answer. Questions on multiplying or adding and subtracting? Cool. Let's talk about multiplying. Now, we have already done part of this. We have done problems like 2 square root of 6 times 7 square root of 3. Let's work out how we did that, shall we? Now, when you multiply radicals, you multiply the parts that are the same. Outside number multiplies with outside number. Inside number multiplies with inside number. So this would give us 2 times 7 square root of 6 times 3, which gives us 14 square root of 18. Now, we're not done because 18 simplifies. 18 breaks apart to 6 and 3. 3 breaks apart to 6 breaks apart to 3 and 2. The pair of 3's multiplies times the outside, and you get 42 times the square root of 2. And that's your final answer. Yes? Now, we know how to do that. So, we're going to take that and we're going to use it to do different types of problems. For example, using the distributive property. Using the distributive property with radicals is just like the normal distributive property. Let's look at this example. We've got 3 square root of 2 times 4 square root of 3 plus 6 square root of 2. First, we have to distribute. We take the 3 square root of 2 and we distribute it to both terms inside. For your first term, you get 3 times 4 on the outside and 2 times 3 on the inside. Plus, when you distribute it to your second term, 3 times 6 on the outside, and the square root of 2 times 2 on the inside. Let's multiply that out. We got 3 times 4, which is 12, and 2 times 3, which is 6. So we have 12 square root of 6. Plus, 3 times 6 is 18. 2 times 2 is the square root of 4. We're still not done, because the square root of 4 is a perfect square, which means you have to take the perfect square, which changes that to 18 times 2. 18 times 2 is 36. So that makes our answer 12 square root of 6. 12 square root of 6 plus 36. And that is your final answer. Try this one on your own. So, remember, you're going to have to pause your video until you get the answer and then play it again. All right, you finish working it out? The answer you should get is 15 square root of 6 minus 15. Let's work out how we got that. So, we distribute 5 square root of 3 times 3 square root of 2, and we get 15 square root of 6 minus 5 square root of 9. Again, we're not done, because 9 is a perfect square. So that becomes 15 square root of 6 minus 5 square root of 3, or 5 times 3, sorry. 5 times 3 is 15. So we get 15 square root of 6 minus 15. Yes? Now, another type of problem that we will have is problems that you have to FOIL. Remember, we did FOIL last unit. And it stands for first, outside, inside, last. Let's do a problem like we did last unit, where we multiplied binomials. So, x plus 5 times x plus 4. First, you do x times x, you get x squared. Outside, you do x times 4, and you get 4x. Inside, 5 times x gives you 5x. Last, 5 times 4 gives you 20. So we have x squared plus 4x plus 5x plus 20. Combine our like terms, which are 4x and 5, and you get x squared plus 9x plus 20. And that is your final answer. Yes? Let's try one with radicals, shall we? We have the 4 times the square root of 6 minus 2 times the square root of 10 times 5 square root of 3 plus 7 square root of 5. You're going to do this exactly the same. FOIL, first, outside, inside, last. First, you have 4 square root of 6 times 5 square root of 3, which gives you 20 square root of 18, because 4 times 5 is 20, 6 times 3 is 18. Outside, 4 square root of 6 times 7 square root of 5, which gives you 28 square root of 30. Inside, we have negative 2 square root of 10 times 5 square root of 3, which gives you negative 10 square root of 30. And last, we have negative 2 square root of 10 times 7 square root of 5, which gives you negative 14 square root of 50. The first thing you should notice is you have like terms right there in the middle. Now, you can simplify before you combine like terms here, but then you'd have to try to simplify 4 different terms as opposed to 3. So, I always look for like terms that I can combine just to make it a little bit easier for myself. So I'm going to combine these 2 terms in the middle. 28 minus 10 is 30. Now, I highlighted 18 and 50 because you're not done. You can't keep those because both of those can be simplified. So let's simplify the square root of 18. 18 breaks apart to 9 and 2. 9 breaks apart to 3 and 3. The 3 multiplies by the 20, which gives you 60 square root of 2. Now let's simplify the square root of 50. 50 breaks apart to 25 and 2. 25 breaks apart to 5 and 5. The pair of 5s multiplies times the 14 to give you negative 70 square root of 2, because 2 is what you have left. Now, that's still not your final answer, because now that you simplified, you have 2 more like terms. When you combine those like terms, you get negative 10 square root of 2 plus 18 square root of 30, and that is your final answer. So, I hope all this makes sense. That's all that we have for this lesson. It combines what we did before, the first unit in this section, multiplying radicals, with what we did last unit, foiling distributive property and combining like terms. So, as always, if you have any questions, feel free to email me. My email is right there, or ingerly@mid-del.net, or you can send me a message on Edmodo. Thanks for watching.